This is the video for 2.1, 2.2, making similar figures by changing size and location. Before we start, we need to review how to write coordinates, also known as ordered pairs. So it's a set of numbers used to locate a point on a coordinate grid. The first number corresponds to the value for x, so the x is always my horizontal direction. And the second value is for the y coordinate, which is my vertical. Okay, so if I was going to find the coordinates of point A, I'm going to go 2 to the left, so that's in my x direction. So that would be going towards my negative direction. So my x value would be -2. And then I did not go up or down at all in my y direction, so my y coordinate is 0. So as an ordered pair, we represent A by saying -2 and then 0. Did not go up or down at all. B is the opposite. So in B, I did not go left to right at all. So in that one, my x is 0. I did not move in the horizontal direction, but I did go down 2 in my y direction. So that ordered pair is 0, -2. Okay. Notice the difference. This is left to right, this is up and down. So A moved left to right, B moved up or down. If they stay on this line, I should have an ordered pair there with a 0. Ordered pair for C, I go over 1, 2, 3, and then I go up 1, 2. The other difference, for D being the opposite, is D went over 2 and then up 3. Okay, so again, notice the difference. My x is the left to right in the horizontal direction. My y is the up or down. So the difference of going over 3 up 2 versus going over 2 up 3. Okay, even though they look very similar, they are different dots on my coordinate grid. Okay, so now let's get into our vocab for today. So a translation is a transformation that slides each point on a figure over a given distance and in a certain direction from my origin point. A with that little apostrophe is the image, meaning it's the new, where A by itself is my original. So a translation produces an identical image, meaning these figures are congruent. It's an important vocab word. Okay, but it simply moved it left to right, up and down, or a combination of those movements. So in this picture, the original A is right here, and its ordered pair is 2, 3. In my new shape, the A with the little apostrophe, the ordered pair is 1, 2, 3, and then up 6. So that tells me I can't multiply these by something to get a scale factor. My shape had to have moved. Okay. I can also see that these pictures look the same. They look congruent to me, so that tells me they probably just went to the left and then up to get my new figure. Okay, so then I can look at these ordered pairs. From 2 to -3, that means I went backwards 5. So triangle ABC moved left 5. And then it moved up from 3 to 6. I counted up 3. So you can give that as a description. My shape should do that same thing for everything else. So we can double check. So this is the original B. The new one has that little apostrophe. Let's double check. Does it go over 1, 2, 3, 4, 5, and then up 1, 2, 3? Yep. Same thing with C. Over 1, 2, 3, 4, 5, and then up 1, 2, 3. So you can check if you'd like to write the ordered pairs for these ones. Okay, but that same thing's happening. Between the x's, from my new to the original, new to the image, I subtracted 5. I went to the left 5. And then for my y ordered pair, I went up 3. Okay. If you'd like to try the extension part of this unit, another way you can write this is x minus 5. That's a way to describe that my x coordinate moved to the left, so it subtracted, and then the y part went up 3. Okay. So on the test, you'll see it written like this. It'll be a description of left or right, up or down. But if you'd like to try the extension stuff in the future, this is another way you can write that as ordered pairs. Our other type of transformation today is a dilation. So a transformation that enlarges or reduces a figure by a scale factor about a centimeter. And then the original figure and its image are similar. So you'll notice in this picture, my point of origin was to the side, so it got bigger in that direction. In this picture, my origin is in the center, so that's why the shape got bigger around that center. Okay, so these are no longer congruent. They are similar shapes, meaning they got bigger or smaller. So let's look at our example. A right here is at 2, 1, and my new A has that little tally right there, is at 4, 2. So how did I get from 2 to 4? Well, this shape didn't stay the same and moved. It got multiplied. From 2 to 4, I multiplied by 2. That same thing happened with Y. From 1 to 2, did I multiply by 2? Yes. So we could say my scale factor is multiplied by 2. Go ahead and double check the other ones as well. So for B, they already gave us ordered pairs here, which is handy. -1 times 2 is -2. 3 times 2 is 6. Over here, -3 times 2 is -6. -2 times 2 is -4. So my scale factor is times 2, and I can say that these two are similar. Okay. A translation above kept it the same shape, and it either moved it left to right, up or down. So those are congruent. It's the exact same shape. But when you get to a dilation, it's going to get bigger or smaller, so those are similar. They have a scale factor, so they got either reduced or enlarged. The other thing as a reminder is if my point of origin is over to the side, sometimes your shape may get bigger away from what you already have. So in this case, the origin was in the middle, so it got bigger around that shape. But if you move that point of origin, your shape will get bigger in a different direction.